Hey guys, this is Manak and today we are going to design a building in STAAD Pro and RCDC combined. That is also called the Advanced Structural Design, and today is we have a building here. You can see this is the ground floor, this is the first floor, this is the second floor, which will be extended further. And you can see this is the architectural plan. We have this is actually a staff quarter, 450 square meter area, and it is almost the similar planning of between all the three floors. So now to do this in STAAD and RCDC, first thing is the column position. So we can see we have positioned the columns here. So I have taken the columns of size 230 into 230 to begin with, and then we'll see what is the size which we get once the design is completed, because 230 into 230 has been selected because the the wall size is 230, and later we can decide what are the sizes which are coming safe, and we'll see all the steps in detail. Okay, so this video is going to be a little bit long. I'm not going to cut or edit the parts out. So if you want to see shorter videos, you can just see my earlier videos also. So I'm just going to, or you can also download the plan and also practice along with the video. Okay, so here first of all we just take this, and for importing in STAAD, we can import by making center lines or in just making the coordinates also. So there is the two methods which are there, and which you've seen in my videos. In this particular video, I'm going to go with the center line method, the coordinate method. So just make the coordinates here. So I'm just making the center lines here for this. So I am also working on this for the first time while making this video, so you'll see a proper thing, not done this before. So horizontal center lines are given for the vertical center line, and just copy this. And this will also cover this, and let's see if we have anything in this area. No, we don't have anything in this area. And this is the layout basically. I think we can give just a secondary beam here just to cover this, right? And staircase, we don't need this. Okay, we need a beam here to cover this, so we'll give a beam. Let's see, beam will be minimum 115 230, so we can give it anywhere. It will 115 will come here. So let's start here with the vertical beams. Let's give it here first. So check the horizontal beams, and then we're going for the vertical beams here, and you can give this side, and do another one here, center here, and the one here. Here, and another one here. So these are the things, and if I think I want to give another this will be closed, so I'll give a secondary beam here just to accommodate this particular wall, and also just to lessen the size of the slab. This will be very close to this beam, I think, so just give a beam here. Or if we want to do this similar, I think then we should give a beam in this direction. So we'll just make it the structure similar and give a beam here. So we are not choosing to add any beams for this particular partition, small partitions here. So this is okay. And now, yeah, we have missed this also for this particular extension also we need to give a beam, and preferably at the center. And okay, we have another extension here, right? So we have already given beam here but not here, so also preferably at the center we need to give a beam. So copy this beam, copy, and then yeah, and extension has been taken. Yes, now all the junctions has been taken, and which we can mark the coordinates, and we can start the plan. Okay, so let's start the coordinates from here. 0, 0. I need to change the size of the text here. It's too large, so just scale it a bit. This is okay. Okay, this is good. So 0, 0, this is the size, and we'll take this thing like this, and these dimensions, vertical dimensions, horizontal dimensions, will take like this, 0, 0. So it's going right, so we'll take this as positive. So it will be STAAD Pro imports in meters, so it will be 2.36. So since this video is going to be very large, I'm just going to show you another coordinates, and then we'll just skip the part. I'll just do it and then I'll turn it on, otherwise the video will be too long. Okay, I'll just skip it, and then let me do another coordinate here for this one. So this one, we have an intersection here, so it will be 2.36, but the other dimension take from here, it will be 1.465. so this is minus 1 point, swing below, so minus 1.465. so this is the coordinate here, and then the next coordinate is this one. Copy this and move it here, and this coordinate, take this one only, just extend this 5.610, and 1.465. so this one has been taken. Now let's see this coordinate here, the next beam junction. So x coordinate is 0 here, this one, copy this, take this to here, x coordinate is 0, and y coordinate is minus 1.93. okay, minus 1.93. this one, only the y coordinate will change for this intersection, it will be minus 1.93 in place of this 1.93. and this one we don't need because the beam will end here, this beam will come here and end here, so we don't need this, and we're not providing this beam, so it are not required. And let's see for the next part here, just take it down to this one, and we take this up to this much. So this is if you just take this, it is minus 4.444, and obviously it is 0. And then this one, I just take another coordinate up to this much, this direction, it is 1000 actually. Column is here, it is minus 1 and minus 4.44. turn the ortho off, and this take this ultimate last dimension, it is 1.5 minus 4.44. so these three coordinates are marked. Now this column will also intersect here, we already have the x coordinate of this, only need to change the y coordinate. This could have copied also, minus 4.444. Now this will intersect here, so there are two coordinates here actually. One we already have. Okay, here also. Okay, this extension is not uh, required actually. Okay, let me see the architectural plan here. Why this extension has been? I think this extension is not required in the plan, but I think it is given for architectural purpose here. So beam will not join, but it is given for, I think, many architectural purpose. It will be a cantilever without for decoration purpose only. So it could be a brick wall, could be give a beam extension here also. Okay, let's give it a beam extension. Let's make it structural. Okay, it's only for the architectural point of view, I guess. So it is 6.415, 6.145. So by the way, this plan is given by another architect, and most of the work I do currently is the architectural plan is done by someone else, and I do the structural drawing. So 6.145, so they'll also give an idea that how to just work along these things. Okay, so the two coordinates here, and these two coordinates will also come upon here, and we'll just change the y coordinate also. So yeah, so this will be fine as 4.44. I'll copy this since I get to do this two times. Simply easier to copy and paste. So just select this and paste it here, and this is done. So this is done, and this is done, and this is done, and this one, next coordinate, this one is done here up to this much. So copy this and copy this up to here, and copy this from here to here. So change the y coordinate. There are no other beams or anything here. Just change the y coordinate from 5. Minus 5.775 minus 5.775. Just copy this and I'll paste it here. So this issue has been solved, and we'll just copy this one. This one will come up to this much, and there is no extension in this part. This one and this one also. Okay, let me just check. Okay, this one. So copy this and copy this up to here. Done. And only change the y coordinate. So we do not know the y coordinate till now. It is 7.474. So just change this to 7.474, and I'll copy this. Similarly, I'll copy this one also, take it down. Let's see the 9.755. And then the next coordinate, we'll take this two. Yeah, this one will take. This one actually suits this style. Yeah, and which is just in the y coordinate. It is 11.455. You can copy this. So 12.78, 12.785. Okay, we have another intersection here. So this one is for this column, and for this intersection also we'll need a coordinate. I was thinking I've skipped this in the top, but I've given it in the top, so paste. Oh, and copied something else by mistake. Okay, I think, yeah, I have like not given this grid. Okay, so I have to give this grid, definitely, obviously. Let me just put this down. And this one also, 1 and 2 and 3 places I need to give. I'm also checking the top floor. No, 1 2 places, and not 3, because I'm not giving this one particularly. So only 2 places I need to give, 1 and 2. So okay, let me just copy from the top, it will be easier. This 2, and let's take the reference as the end. That would be easy. And only need the y coordinate, so just extend this line. So it is 15.30. Just change this. $15.765. Copy. Okay, done. So this one will take, and this one I'll take. Now final, only the y coordinate will change. What is it? 17.230. So if I do it without recording, I'll just take a little bit less, or much less time, without commentary, but I'm just trying so that you guys can also benefit from this. So if you like the effort, make sure you drop a comment. Okay, and also the like, just increases the reach of the videos. So here we have completed this coordinate marking. Might miss 1 or 2 things, but I think, yeah, we have completed most of all the things. So once you do it, just check whether everything is remaining. Okay, and after this process, just press Ctrl plus S, and I'll open the file for STAAD. So let's open STAAD Pro. Okay, yeah, before opening STAAD Pro we need to mark the coordinates also. Let's do that. Cell worksheet. Because I don't want to mark the coordinates, sorry, mark the coordinates indirectly in so that I can, if anything goes wrong, I can change it. Number. So we have to then take it note by note. Mm, 2.36. Next level. I'm marking the plinth level, so I'm taking the plinth level as 0. I also mark the points which are columns so that I can have it easy. So I'll just mark a C next to it. So this is we have a column here. So when we just taking the translation repeat, it will be easier for me. Okay, so that's why I'm doing this. 2.36, 5.61. 5.61, and the coordinate Z is Y in Z in STAAD Pro is Y in AutoCAD, so minus 1.465. Oh, we have another one for that. We just two point three six zero. Okay. So for 0 we have 0 and 2.36. For minus, let's do minus 1.465. This is also 0. Copy and paste. And this is minus 1.465. Okay, and for minus 1.465 we have 3 coordinates. Okay, so we can copy this and paste it in this too. Okay, so and y also, y, there is, you can just paste it everywhere. A lot of points will be there. Just do it that for now. And the 3 are 2.36, and then we have 5.61 and 6.145. 5.61, just verify, hit double check it, and 6.145. The columns in this, we have 5.6 as a column point, so just take this column point. Okay, in fact, we can just bold out this also. Right. Yeah, 6.15. Now let's move on to the next round. It is minus 1.93. No columns here. Just write minus 1.93. No columns here, and 0 and 2.36. So just 0 and 2.36. 2 points we have. Okay. There are no other points here. Okay. So we move on to the next. It is minus 4.444. Minus 4.444. So number of points here, 1, 2, okay, 3, 4, 5, and 6 number of points apparently. So just 2, 3, 4, 5, 6. Paste it, and let's start here. This is minus 1.5, minus 1, 5, minus 1. And then what we have 0, 0, we have 2.36, and okay, then I think I can copy 2.36, 5.61. Yeah, this 2 I can copy, and 6.145 also I can copy. 2.36, 5.61, 6.145, 3 things I can copy, and yeah, I think only have these 3 things only. Next, let's move to my minus 5.775. We have 2 points on this. Minus 5.775 means 2 points. Copy and paste. So what are the points here? Earlier there were any? No, there was the first time So it is, yeah, minus 1.5 and minus 1, minus 1.5 and minus 1. Just copy these two and paste it here. So this is done, and the next will be minus 7.474. So let's do minus 7.474. Okay, and then it is minus 1, obviously minus 1, and then it is 2.36 and 6.145, 2.36 and 6.145. Just copy and paste it here, and this is done. This is done. Minus 1, 2.36, minus 1, 2.36, 6.145, the same thing here, and then this is 9.7. So next, 2.36, 6.145. Get 1, 2, 3. So minus 15.3, next one, 4, and minus 15.3, 2, 0, and 2.36. Hmm. 0 and 2.36, and then 2.36, and then we have next 15.765. 2 points we have. They have 2.36, 6.145. Oh, we should have 3 points. Actually, this is the teacher point of view. Yeah, as usual, we have missed a point. No, I think we have not. Actually, this is not 6.145. This is actually 5.610. Yes, that makes sense. This is 6.115, and this is 5.610. Okay, this makes sense now. Okay, so 15.765, 1, 2, and 3. Okay, so we have 2.36. Already have 2.36, and then 5.610. Oh, I forgot to mark the columns next. Sorry, should have done it. 5.610, and then 6.145. This is the column. Check the starting. So don't make these errors like me. Obviously make. Okay, in 12.0, in 15.76, and then you go 12.785, then you have -1, 2.36, and 6.145. 12.75, you have -1, -1, 2.36, and 6.145. Am I right or am I right? Yeah, right. And in 9.705 also, in this three we have 9.705 also, -1, 2.36, 6.145, and then we go to, let's minimize it, and then we go to 7.44. then out there also this 3, -1, that I have tested here like this. I think it's -1, 2.36, 6.145. Then we go up to 4.44, there also this 3, -1, here we have 0, right? -1, -1, 2.36, 6.145. Okay. This is done like this. It's done like this. Columns are marked. Okay, yeah, we have another dimension, 17.23. So it is -17.23. Copy and paste. Two dimensions I saw, I think. Two dimensions, 0 and 2.36. Okay, the columns, I think, yeah, the columns. Yes, now 35 points we are having here. So oh, sorry, this is not MS Excel, forgot. So these are the points which we have. Now we can open STAAD and just new project. This is more. Metric. This is the object location here. Great. Select, copy, paste. Top view. So the node was okay. Just the way I did marking. If you do the bottom view, then you can see the plan better. Okay, so let's continue from these here. So this is the top portion here. Let's continue like this. No problem in that. Firstly, let's see which one should join and which one we should not join. This one don't need to join, this one will join. Okay, so this one will join, this one is just for show. For architectural purposes, this is there. Let me check whether this is required or not. Yes, we are here. We'll obviously go down and go like this, right? this one also we'll check. This is going to join like this, this is like this, and this one like this. Just checking. Yeah, obviously join like this because the main beam to beam connection will do that. And then go beyond this. This portion is pretty simple. Check this portion. We have a column to column connection here. These are the columns. Okay. So this portion, the column is here. So I think I missed a coordinate here, right? This column is here, this beam is joining here. So 5 point, yeah, I didn't even mark it in the AutoCAD, so definitely I missed it. This is the coordinate which I missed. So it's 5.610. Just correcting this so that in future I don't have to do this. 5.610 minus 12.785. This is the coordinate. You have to insert. Let me insert it directly also. Can insert from Excel also. 36 number, right? Let me insert from Excel. 36. 5.610 minus we have 1. And the other coordinate is 12.785. Get a new column. Just copy this and paste it like this. Paste it here. Let me delete this and I'll add the beam again. Column to column will come like this. No, this column to column will not come like this actually. Into Ctrl + Z, yeah. This is the column and this will come like this. Is only for decoration purpose. So this is the structure here. You can see this is the structure, and we'll see what are the requirements in this structure for the plinth level. Okay, let me check. So these are the initial requirements for this particular building and the plinth height here. So the total depth up to the foundation will be 2.6 meters. So we'll take this as 2.6 meters. So what I'll do, just go to Excel and copy this coordinates here. Which has the columns actually. What I'll do is just paste it here, and then the coordinates which has the columns, I'll only keep that, and control and delete the other coordinates which do not have the columns here. You can apply any other method also. Deleted those, and Ctrl C, Ctrl V for those, and can delete should have done this in the earlier step. One and 18 number of columns. Let me just verify this from this 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18, right. So yeah, this is type. So plinth height will just 2 here, 2 minus 10.6 minus 2.6, and I'll just copy this and paste it over here, and this will be 37, and continue this, and we just double check from there here. So up to 36 we are having, from 37 we'll start. So we'll just copy this, Ctrl plus C, Ctrl plus V, okay. Now view and geometry, add beam layout, let's rock. So once this is done, I'll just check here, select beams parallel to Y, just for checking that 1 2 3 4 5 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So 18 number of columns are there. So we are satisfied with this arrangement, and then we'll go up, further up. So to go up, we'll go to view, and we'll go to front view, and we'll select this point, and we cannot use translation add steps, so go translation repeat Y minus what is flow to floor height, it is 3 meters. So yeah, so okay 3. Number of steps will be 1 for now. Now let's join the points where we have the columns. To make the things easier for us. So let's check whether there is 18 things there. Let's check here. Okay, on the isometric we also can check, like select parallel to Y. So there is no half things, all are full, so it is okay. Now since it's okay, we'll simply go to view, we'll go to front view, and we will select this, and we'll just select let me apply the slabs here also. Hmm. So where we have any provision of staircase? Yeah, in this portion I think entirely we have the staircase. Yeah, this only this one, because this is the staircase to just to climb this. So this portion there will be no slab, and remaining portion there will be slab. So we'll go to geometry, add plate. To design properly you can go to parametric modeling, but here we don't need that. How many I've added? Two. Left one I'll leave for stairs. Yeah, only the stair one is remaining. So go to view, go to front view, display whole structure, go to front view again, escape, select this entire thing. Can I select the slab also in one go? Let cursor. No, I cannot. Okay, no worries. Let's go to beam cursor, select this, geometry, translation repeat, Y, 3. So this is a G plus, I think, yeah, G plus 2, 2 steps. Okay, 2 steps will be there. So now I have to go view, obviously geometry, no, select plate cursor, select all the plates here, geometry, translation repeat, Y, 3, and spacing, number of, yeah, this 2. Once it's done, I'll check view, 3D view. Yes. So we are okay, continuing recording, right? So just checking. So next we go to properties. Properties, I'll define some properties here. Rectangle, and what's the 0.23 into 0.23, the column properties, right? And the beam property is like clean beam. Let's go. I think clean beam will pass at, let's go 230 to 234 of the beams as well, but let's just keep it separate. And another one also 230 into 350. This is for the roof beam. And this one, just make this, edit this, make this 300. 230 to 30 is too less. 300. Oh, I just missed it, sorry. 0.23 into 0.3, change, and this one will be Control X, cannot change this, 0.35, 0.23, change and close. This one, view whole structure, select parallel to Y, assign and yes, and then select this view, front view, and select this and right click, and then sorry, just apply right, select this and select the beams, assign and yes. For the roof beam, select the roof beam here like this, and like this, and like this, and assign. Right, then is assigned, and then we go to the materials. Concrete by default it is taken, so nothing need to be done. Specification, just don't need to do this. Go to support, create a fixed support here, and select the support, assign it, assign and yes. So you can see in the whole view also. Then you go to loading, and loading, okay, before go to loading, just see, view the structure here. Okay, the structure is ready here. Okay, then loading, first of all seismic definition will add, and seismic definitions, this one. Okay, select your code, country code, zone 3. I'm going OMRF here because it's zone 3. You can go with SMRF for zone 4 and zone 5. So 200, less than 200 occupancy, so I'm going with this soil. Soil is actually very hard, so damping ratio, foundation depth is 2 meter, cement resting frame, time period you can change in X and Z direction here for proper analysis, so we'll do that. This is the formula. So the height of the building here will be taken as, for this height of the building, H will be taken from ground level. It will be 0.6 plus 3 into 4, right? 3 into 4, and it will be 3 into 4 is 12, and 12.6 is the height of the building, 12.6 meter, and dx in x direction, dx is equals to, just I can see just simply tell from the AutoCAD, and x direction, the maximum thing which is going here, it is 15 point, let's take 16, 15.765, so let's take 16, that's a 16 meter, and dy is 17 meter something, I think. Let's take this, this is 0 starts to 17.23, so let's take 17.3, right? 17.3 meter, sorry, 3 meter, and then time period in x direction, dx, it will be, I'll just calculate using my calculator, into h 12.6.009 into 12.6 divided by root over 16. 16 comes as 0.03. Ty is equals to, and this is root over 70.3, which is also 0.03, 0.027 actually it is, okay, and taking two places it is also 0.03. So let's go. Remaining cases obviously we'll add in the STAAD editor. If you add load combination, there is no need to add HL plus X plus Z, because in load combination anyway plus and minus are considered, so there is no requirement for that. Let's set floor finish load. Minimum wire range start from 3, so let's do 2.9, and it will go, let's take 30 and dead load, let's take dead load for walls. How much? 0.23. Let's take, I think all the walls are 0.23 here, so let's take everything 0.23. What is the load here? We just calculate 0.23 into 20 into it is 3 actually, 3, and beam size 0.3, 2.7. If you take 2.7, it will be 0.23 into 20 into 2.7, 12.42, right? Let's take 12.4. So floor loads, number load minus 12.4 plus view to structure, self weight assigned to view, wiring already assigned, this one front view, control select this, control select this, live load, flow load minus this is 2 residential, 2.9 and 30. Send it. Live load added, this added, and you need to just go to control plus S, and then we need to go to this command file. Earlier it was called STAAD editor file. Zoom in because I'm old, and then what is dead load? Dead load, this one, flow load, member load, this one, negative sign on this remote, and this will be WEIGHT, negative sign direction remote, and this is also WEIGHT, negative sign and direction remote. Weight, then floor weight for the live load will also take this one, and percentage will be taken, obviously it will be 25%, and WEIGHT 25%, that is, it will be 0.5. Okay, 2 into 0.2, 25% of 2.5 we've taken. Control plus S, close this. Yes. If you have any error, generally this will show, and that is you have noted some errors, but it's okay. So just go to the analysis, and model analysis also you can check. Okay, yeah, the structure is stable or not. I'm just skipping that part for now, and don't forget to add the analysis command. we want to check everything, not applying model analysis and also not doing that, no print. Otherwise if you want more model analysis, just click on all and click on add. Okay, so I'm just going to design some basic things. Let's just give in the design concrete, and obviously the concrete code 456 456, and then we select the parameters here. Some minimum parameters I'll select. Let's say FC, we'll select FY main and FY secondary. Okay, this only in this two define parameters. FC 25 1 2 3, add FY main, let's go 500 parts 1 2 3, add FY secondary 500 1 2 3, click on add and close, and I'll select this, select, okay, just assign to view. Mostly because structural fail, I have not applied any load combinations till now, so some members might pass but maximum will fail. Your output file. Okay, so member properties have been, oh, I'm not inside the properties of slab, sorry. Properties, go to thickness 0.15, let's take the thickness of slab, close, and assign to view, assign, and yes. Now we go to analysis and design and run analysis. There were some warnings, one warning, okay, so members are passed. I'm surprised those are not passed actually. You can see no member have passed because it was obvious we need to increase the size. So if you go to properties, first of all let me just increase the size of the column here. I think 0.45 would do. Change it. This size 0.30 into 0.45. Edit 0.30 into 0.4. Okay, I have not added the things what is happening to me. Just go to concrete, go to commands, design beam, design column, and take off for the quantity estimation. Design beam, go to select parallel to X, parallel to Z, assign, and yes. Design column, parallel to Y, assign, and yes. And then we go and analysis and check. 49 warnings means 49 things have failed. Okay, but some members might pass. You can see here the concrete design here, part size 8. I think all the columns might have passed. 8, 16, 8, 12. Okay, the members which have failed you can design here or you can just design in RCDC. Okay, best thing is to you design these things in RCDC, right? So if you want to design this in RCDC, first of all save this file, and then we go to advanced concrete design. So firstly we'll start with the design of column. Okay, so we'll start with the column here and create new project. So first we'll for the column, So the data is being imported, and then we'll first of all go to level data, and then here we'll just do FE550, and cover will be 40 mm cover will do. Then copy this too, and then paste it here. Then now I'll just go to design, and we'll just define this seismic loads, earthquake X and earthquake Z, and then dead load, and then live load, and then select the loads here. So we'll create some load combinations and click on OK, and the structure will analyze, and you can see all the numbers are passing here. So we can just reduce the size also and try to make them more economical if possible. So I will just unlock the design and go with the design input, and column size here, can just change the column sizes from here. Okay, and then we can just redesign it once again. Okay, so like this, we change it here and redesign it again. So like this, you can change the section, or you can change this instead and redesign the columns again to make them more economical. So we can do this, and after that let's go and see how the beam design is done. So, and the foundation design is done. So we'll go to file, and we'll go to, let's save the file first. So after saving the file, and then we'll do the next design. Okay, so we'll just have this more project settings. Okay, we can exit this as well. So then we'll just close this advanced concrete design. Okay, so yeah, I have just reopened the file, so that's why the necessary to be done again. No problem with that. So advanced concrete design once again, and here we will just go and do the, okay, this will be for the footing. Now for the footing, we'll just do some input settings here. SPC, here it will be SPC is 220, and M35 and FE550. This is taken, click on OK. Design, define the loads, load, live load, just select and do it here. Okay, and, sizing, these are vector load combinations, and the footing design is done. And you can just check the results from the reports, schedule, detail scheduling, everything can be saved in your AutoCAD format. So we'll save the file, and I'll close this. Again, we click on the advanced concrete design, and this time we'll go for the beam design. Let's take the example of plinth beam. Plinth beam is at 0 level, so check in the plinth beam here. 300 or 400 was the default size, so the plinth beam here. So let's check. So I had changed this FE500 also, I have to unlock the design to change this. Go to settings and general reinforcement settings. Just change this to 550. Okay, and then you can redesign this. So you get the beam design for this as well, and you can generate the reports, text schedule. Okay, and if you want a ductile design, make sure you just tick the ductile designing. Now it's locked, but you check the ductile designing in this place, and you can also generate the, you can just save this file. This file is saved in AutoCAD format, and you can also check the elevation and section and bill of quantities and other things as well. So this is the procedure in which you design a full building in STAAD, and then uh, do the remaining steps in RCDC for the detailing, so that you can get generate the schedules and sections and VPS and everything. So hope this helped, and keep learning. Bye bye.